In this episode, we are moving past the more familiar Windows screens and into the tools technicians use when a problem is real, but the cause is still unclear. A computer may be slow, startup may take too long, memory may seem to disappear, or a feature may behave strangely even though nothing looks obviously broken on the desktop. That is where deeper troubleshooting tools start to matter, because they help you look underneath the surface instead of guessing from symptoms alone. For a beginner, the goal is not to become an expert in every hidden part of Windows all at once. The goal is to learn that good troubleshooting comes from evidence, and these tools help you find that evidence by showing resource use, startup behavior, stored settings, system history, and the background parts of the operating system, OS, that users usually never see. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. One of the biggest differences between a beginner and a stronger technician is not speed. It is the habit of asking better questions before making changes. If a user says the computer is slow, that could mean the central processing unit, CPU, is overloaded, storage is busy, too many startup items are launching, a background service is stuck, or the system is short on random access memory, RAM. If a user says Windows acts weird, that could mean a startup setting changed, a scheduled task is firing at the wrong time, or a system setting was altered in a place most users never open. The deeper Windows tools are helpful because each one answers a different kind of question. When you know what kind of clue you are looking for, you stop bouncing from screen to screen and start building a simple picture of what the machine is actually doing. Resource Monitor is one of the best tools for beginners who need to move from a vague complaint to something concrete. It gives a closer look at how the system is using processor time, memory, storage activity, and network traffic, which makes it much more useful than a simple feeling that the computer is busy. A user may say everything freezes for a few seconds at a time, but Resource Monitor can help show whether the slowdown is tied to heavy disk use, too much memory pressure, or one process that keeps grabbing system attention. That matters because different slowdowns call for different thinking. A machine that is waiting on storage behaves differently from a machine that is out of memory, and a system that is busy on the network creates a different kind of clue from one that is stuck reading and writing data all day. Resource Monitor is especially useful because it helps you see relationships, not just raw numbers. A beginner might notice that memory use is high and assume that high memory always means a problem, but the better question is whether that memory pressure matches the bad behavior the user is reporting. The same is true for storage and network activity. A short burst of activity may be normal, while constant heavy use tied to one process may explain why the computer feels slow, why an application hangs, or why the fan runs harder than expected. This is why Resource Monitor is not just a more detailed status screen. It helps you connect a complaint to a system pattern, and once you can connect the symptom to a pattern, you are much closer to choosing the right fix instead of making random changes that only seem logical on the surface. The System Configuration utility, which technicians often open with msconfig, is useful when the problem seems tied to startup or boot behavior. If a computer takes too long to become usable after sign-in, if a user says strange programs always appear at launch, or if Windows behaves differently after a recent change, this utility helps you think about what is loading and how the system is starting. For beginners, it helps to think of this tool as a place for startup control and startup testing rather than as a place to fix everything. It gives you a better view into whether background items, startup choices, or boot-related settings may be changing the way the system behaves before the user even begins working. That is important because many support problems are already in motion before the desktop fully appears, and users often describe the result without knowing the source started much earlier. The value of msconfig is not that it makes Windows faster by magic. Its value is that it helps technicians isolate whether startup choices are part of the problem. If the machine behaves badly during normal startup but acts much more normally under a reduced startup condition, that is a clue that extra items loading with Windows may be contributing to the issue. This helps turn a fuzzy complaint into a cleaner question. Instead of saying the computer is just bad in the morning, you can begin asking whether a startup item, background process, or boot setting is making that time of day worse. For a beginner, that is a major step forward. You are no longer treating the whole computer as broken. You are narrowing the problem to what happens during startup, and that makes every next step calmer and more logical. Registry Editor often scares beginners, and that reaction makes sense because the Windows registry stores many important settings that affect how the system and applications behave. The easiest way to understand it is to think of the registry as a large database of configuration information. It holds settings for Windows itself, for hardware behavior, for installed applications, and for many user and system choices that are not stored in simple files you browse every day. That is why Registry Editor matters in support work. It helps technicians inspect or change settings that may explain odd behavior when the normal Windows interface does not show the full picture. At the same time, this is a tool that demands care. A small change in the wrong place can create new problems, so the lesson for beginners is not to become reckless with it. The lesson is to respect what it controls and use it to understand system behavior before assuming a problem has no explanation. A helpful beginner mindset with Registry Editor is to treat it more as an investigation tool than a first-choice repair tool. If a setting seems to return after every reboot, if a feature behaves differently for one user than another, or if some system behavior looks too specific to be random, the registry may hold part of the answer. The registry is often involved when Windows or an application remembers a choice and keeps applying it in the background. That makes it valuable when you need to confirm whether a setting exists and whether it may be influencing behavior behind the scenes. But good technicians do not open Registry Editor and start changing things because a machine feels strange. They use evidence from other tools first, then use the registry carefully when they have reason to believe a stored setting is part of the issue. That order matters because it keeps support work deliberate instead of risky. System information is another strong tool because it answers a different but very important question. What is this computer really? Users often describe their systems in broad ways, saying a device is new, powerful, upgraded, or fully supported, but technicians need more than a description. They need facts about the hardware, installed components, basic system details, and the current environment. System information helps with that by gathering many of those facts into one place. It may not be the most exciting screen in Windows, but it is useful because troubleshooting gets easier when you know what machine you are actually dealing with. If performance is poor, startup is unstable, or a feature is missing, you need to know whether the system has the resources, components, and configuration to support what the user expects before you chase more complicated explanations. That keeps you from wasting time on ideas the hardware could never support in the first place. Reliability tools are also important because some problems are not best understood through a live view of the system. A computer may seem fine when you look at it, but the user says it crashes every few days, freezes after certain updates, or started acting up only after a specific change. In cases like that, the technician needs a timeline, not just a snapshot. This is where history-based tools such as Reliability Monitor and Event Viewer become helpful, because they show when trouble started and whether the same kind of issue keeps appearing. For a beginner, this is a big improvement over guessing from memory. If you can see that problems began after a driver update, an application install, or a pattern of repeated failures, you now have a starting point grounded in evidence. That does not solve the issue by itself, but it tells you where to look next and helps you stop blaming the wrong thing. Services and Task Scheduler also help explain behavior that seems random until you remember that much of Windows works in the background. A service can support printing, updates, networking, security, or other system functions without the user ever opening an app by that name. A scheduled task can launch cleanup work, checks, updates, or other actions at set times or at startup. If a user says the machine slows down every afternoon, loses responsiveness after login, or keeps performing some action they never started themselves, these tools help test whether the system has been told to do something automatically. For beginners, that is an important lesson. Computers do many things because they were instructed to do them earlier, not because they suddenly became mysterious. Once you check the background layer, behavior that seemed random often starts to make sense in a very ordinary way. Another useful tool in deeper Windows troubleshooting is Performance Monitor, though beginners should keep its purpose simple at first. It is there to help track and measure system behavior over time rather than only in one quick glance. That makes it helpful when a problem builds slowly, happens on a pattern, or needs more detailed measurement than a short live check provides. A technician may suspect the system becomes overloaded during certain tasks, but a brief look at the machine may miss the moment when the real strain happens. Performance Monitor helps by giving a longer and more measured view of what the system is doing. For a beginner, the key point is not to master every graph. It is to understand that some problems need more than a quick peek. They need patient observation, and this tool supports that kind of evidence-based thinking. What makes these utilities so valuable is not that any single one tells the whole story. Their strength comes from how they work together. A user says the computer is slow after startup, so you look at startup behavior with msconfig and check active resource use with Resource Monitor. If the slowdown began after a certain change, you look at reliability history. If a feature behaves strangely for only one account or after one specific setting was changed, the registry may matter. If the machine seems underpowered for the work being asked of it, system information helps you confirm the facts. This is how technicians move from guesswork to evidence. They stop asking one tool to solve everything and start using several tools to build one clear explanation of what is happening. Beginners also need one very important warning with these deeper tools. Seeing more information does not mean making more changes right away. It is easy to get excited when you find a setting, a service, or a startup item that looks suspicious, but support work is safer when you change one thing at a time and connect that change to the problem you are actually trying to solve. If you disable several startup items, adjust services, and edit the registry all at once, you may lose track of what helped and what created a new issue. That can make the system harder to recover and harder to explain. Good technicians use these tools first to understand, then to test carefully, and only then to make changes with a clear reason. That order protects both the machine and the person depending on it. By the end of this discussion, the main idea should feel much more practical than scary. Resource Monitor helps you see where system resources are really being used. The system configuration utility opened through msconfig helps you focus on startup and boot behavior. Registry Editor helps you inspect deeper stored settings when the usual Windows screens do not tell the whole story. System information gives you hard facts about the machine you are supporting, while reliability and event tools help you build a timeline of what went wrong and when. Services, Task Scheduler, and Performance Monitor add even more clues about background activity and patterns over time. When beginners learn to use these tools as ways to gather evidence instead of as mysterious expert screens, Windows troubleshooting becomes clearer, safer, and much faster. That is the real goal. You are not learning hidden tricks. You are learning how to ask the computer better questions and listen carefully to the answers.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.